Okay, now we're ready to go. Okay, here we go. I'm going to hide this. Looking at that, what's a way to find the distance from A to B? What do you think, Chase Sturwald? How would you find the distance from A to B?
Add them together.
Add them together. Negative 3 plus 5 is 2. Are they 2 apart?
Count the numbers in between, or
Count?
yeah.
Count would work. That's one way of doing it. Ryan, not Ryan. Okay. Let me think, because I know your name. I gotta think. Okay, I give up. Thomas Meckles. Yeah, I should have known that. Thomas, what would you do?
Add the absolute value of both the numbers.
Add the absolute value of both the numbers. Yep, that would work. 3 plus 5 is 8. They're 8 apart. That will work. Anybody have a different way, Tate? You could subtract negative 3 from 5. 5 minus a negative 3 is 8. That works too. Okay? So, when you're doing this, which method of those 3 methods was the best? What do you think is the best, Illy?
I'd say adding them together with the absolute value.
Adding together the absolute values. Okay. What if, Illy, we were at 2 and 5? One point was at 2 and one point was at 5. And you took their absolute values and added them together. What's 2 plus 5? 7. Would that be the best way of doing that one? No. If they're opposite signs, you'd add their absolute values. Okay. But if they're at 2 and 5, that wouldn't work. So which methods would work? Would Chase's method of counting work? Would Tate's method of subtracting work? Okay. So those 2 methods would work. Which is best? Well, does it always have to be the same situation for the best? Because if they're like 2 apart, I would just count instead of trying to subtract. But if they're 34 apart, what would you do? Subtract instead of trying to count 34 numbers. So it all depends on the situation, what you need to do. So that gets your minds into thinking about number lines. And here we go with vocab. Okay? In geometry, we start out with undefined terms. Our 3 undefined terms in geometry are point, line, and plane. A point is a location and has no size. So a point is represented by a dot and a capital letter. Then we get to a line, and a line is an infinite number of points on a straight path that extends in opposite directions and has no end and has no thickness. Basically, it goes on forever in both directions, and that's what a line is. All right, and a plane is an infinite number of points that lie on a flat surface that extends without end and has no thickness. Okay, so a point is one point, just a dot, somewhere out in space. Okay? A line contains how many points? At least 2 points. You need at least 2 points to make a line. A plane has how many points? At least 3 points. So a plane has to have at least 3 points. An example of a plane in this room is like a wall or the ceiling or the floor. Those are all planes, two-dimensional objects. A line is like in the ceiling, there's all kinds of lines, but imagine they go on forever in each direction. Okay? So, point, line, plane. That's what everything in geometry is defined from, is those undefined points, those undefined terms. Okay? Point, line, plane. Now, as we said, point uses a capital letter. A line uses a lowercase letter or else the 2 points, 2 of the points in it to name it. And a plane, you can use either a capital letter to signify it in the corner or at least 3 of the points to name it. All right. We will go on to define terms now. A segment is part of a line, and it has 2 endpoints. And it contains all the points in between those 2 endpoints. So a segment is part of a line. A line never ends. A segment has 2 endpoints. So when we name a segment, we name it using its endpoints and have a segment symbol over the top of it. A ray is part of a line that has 1 endpoint. So a segment has 2 endpoints, a ray has 1 endpoint. And it goes through another point and keeps going on forever. So it goes on in one direction forever, not both directions forever. An array uses the 2 letters, the endpoint, and then another point that it goes through to name it, with a ray symbol above it. Now you could have opposite rays that have the same endpoint and lie on the same line. So basically, opposite rays are two rays that go in opposite directions, and they basically form a line. So ray TS and ray TU are opposite rays. And finally, of the terms that we're going to define right now, an angle is formed by two rays with the same endpoint. Each ray is a side of the angle, and the common endpoint is a vertex. So where the two rays start from is called the vertex of the angle. So point 2 is the vertex of the angle. So you can name that angle by calling it PQR or RQP or angle 2 or just angle Q. Okay, that was a lot of writing in a short bit of time. Now, let's go back to opposite rays ones. TS and TU are opposite rays. Are US and SU opposite rays? Are ray US and ray SU opposite rays? And Thomas says no. And Thomas is correct. They're not opposite rays. Why not? Why wouldn't SU and US be opposite rays? Well, looking at the definition, they have to share what? Share an endpoint. Okay. SU has the endpoint of S, and it keeps going through U forever. So it only has one endpoint, S. The ray US has the endpoint U, keeps going through S and goes on forever. It has the endpoint U. They don't share the same endpoint. They may be going in the opposite direction, but they're not opposite rays because they have to have the same endpoint. And then with an angle, there's various ways to name an angle. You can use just the vertex, a number inside of it, if it has a number there, or you go from one side to the other side, so PQR or RQP. You cannot name this angle RPQ. You always have to have the vertex in the middle when you name an angle. Now, if there's two angles at the same spot, then you can't just say Q because you don't know which angle you're talking about. Okay? So, you gotta be careful there. All right. So, now, the ruler postulate, and we'll talk about postulates here in a little bit, about the definition of postulate in a little bit, so you don't have to write down postulate yet. But the ruler postulate does this. It allows us to say that somewhere we can assign a ruler to a line where we can match up coordinates to a ruler. So x belongs to 3, y belongs to 7. So then we can find the distance from x to y. And this is where we can subtract take the absolute value of what we subtract. Okay? So when we're talking about the first distances right at the start, okay, this is what we want to do. Take and subtract them and then take their absolute value. Okay? All right. Next vocab word, postulate. A postulate is a statement that we assume to be true, no matter what. We assume a postulate to be true, no matter what. So a postulate is a statement that we assume to be true. So the ruler postulate allows us to find the length of KL. So K is at where, Ray? 12, and L is at? So what is the length of KL? 4. Okay. All right. So then we come to the segment addition postulate. That's another postulate. Oh, now I got to sign in. Different computer. Got to sign in. Really? So the segment addition postulate says that if we have a segment, to figure out how long AC is, we can take AB plus BC. AB in this case is 5, BC is 5, so AC must be 10. Now if I move this, here AB is 5.86, BC is 5.86. So if you add those two together, AC is 11.72. If AB is 6.92 and BC is 2.78, you add them together to get 9.7. That's what the segment addition postulate is. You can take two segments, add them together to be the whole thing. Okay? So here, segment addition postulate. Okay? They say GH is 16. This part from here to here is 16. Okay? FG is here to here. We want to know what FH is, this whole thing from here to here is. Well, before we can do that, we got to do a little algebra. Ooh, algebra. Some of you had Cradaville last year, some of you had Hodgin last year, but what algebra equation do we have to set up to figure this out? Because to figure this out, we need to know what is. We need to know what x is. We need to know what x is. But how do I figure out x? Well, I have a 16 here and a 2x plus 2 here. What would you do with those? How would I set up an equation with those two in it, Ainsley? Set up an equation. An equation has what in it? Ainsley? What type of a sign? An equal sign. Do you see any two things that might be equal there? If this is 16 and this is 2x plus 2, they are equal to each other. So 2x plus 2 should be equal to 16. Now we got to solve this. How do we solve it, Mia? Subtract 2. 2x equals 14. And then divide by 2. X equals 7. Okay, so I have x equals 7. So this is 16 here. But I got to figure out what FH is. So I got to figure out what FG is. How do I figure out what FG is, Jack? Take 7 times 3, which is 21. Put the 3 right there. That's 21 minus 1, which is 20. So this part is 20. This part is 16. Visually, that doesn't look correct because FG you would think should be longer in the picture than GH. But hey, this is geometry, and the pictures are sometimes off. But to find FH, it's 20 plus 16, which is 36. That's the length of FH. All right. These points are collinear, which means they are on the same line, which means we can use a segment addition postulate. So on your vocab sheet is collinear points on there? Okay. So collinear points mean they're on the same line because if we look at it, the base word of collinear is line. They are on the same line. Collinear points are on the same line. Okay. Segment addition postulate. KM is 67. This whole thing is 67. How do I figure out what LM is? Well, if that whole thing is 67, how should I set up my equation? What equation would you set up if we know this whole thing is 67, Micah Nelson?
Maybe you would divide?
We want to divide. Okay, segment addition postulate. We want to add some things up here. What parts are we going to add up, Cambry? 5x minus 12 doesn't equal 67, no, because this whole thing equals 67, not just the 5x minus 12. So what other part do we need to add on to that? What do we need to add on to that, Jordan Peterson? 4x plus 7. So if we take the 4x plus 7 and add on to the 5x plus 12, we can set it equal to 67. All right. All right, we got to go back to Algebra 1 again last year. Okay. At this point of the equation, we need to combine like terms. Combine like terms. So, Mr. Gabriel, what do I mean by combine like terms on the left side of my equation? Yep. So 4x and 5x make 9x. 7 minus 12 is negative 5 equals 67. All right. Now I need to solve that equation. How do I solve that equation, Ella? Add 5. So 9x equals 72. And then what would I do, Ella? Divide by 9. X equals 8. All right. So do I know LM yet? Isaiah Lucas, how can I figure out LM really quick here once I know x equals 8? Yeah, plug 8 right in where x was. 5 times 8 is 40 minus 12 is 28. LM is 28. Lots of algebra going on there. Okay, so those of you who forgot everything over the summer, well, you got to get your brains moving again. Get those cobwebs out of there because we're going to be doing a lot of algebra this year. Okay, next postulate. We had the segment addition postulate, the ruler postulate. Now we have the protractor postulate. Now you got to know how to use a protractor. Okay, so if you have an angle, and if I want to figure out angle ABC here, ABC, I look where the 0 is at. A has a 0 on the outside. So I'm going to use the outside numbers to find ABC. If I want to figure out what CBD is, CBD, over here, D has 0 on the inside numbers. So we got to use the inside numbers to find CBD. So Aiden, how big is angle ABC? 60 degrees for angle ABC. And then, Olivia, how big is CBD? 120 degrees. All right. So, we need to figure out what BEC is. Now, BEC, neither one of them starts at 0. B is out here, C is here. So I got to figure out how many degrees just plain and simple B is. Okay? So let's use this outside, Amiria. And what would you say B would be approximately? About how many degrees? Bigger than 45, because 45 is right here. So, what?
47.
47, that's what I would say. I would say 47 degrees. And then where would C be, Amiria?
108.
Well, here's 110. It's halfway in between, which would be 105, yeah? Okay, notice how Mary used the outside scale for both of them, because we have to use the common scale. If they're not starting or ending at 0, when we're finding two that are in between, we have to use a common scale. So we choose the outside for both of them. Okay, we have 105 and 47, but neither one is the right answer for how big BEC is. So how do we find BEC, Caitlin? Subtract them. Take 105 minus 47. 15 minus 7 is 8. 9 minus 4 is 5. It is 58. Okay, the angle addition postulate. Let me go here, and it'll log me in. So the angle addition postulate is like the segment addition postulate. You can take one of these points and move it out a little bit. Oh, come on. Now I did it. Now you can't see the numbers. All right. So the angle addition postulate just says one smaller angle plus one smaller angle equals a whole big angle together. 41 plus 65, 60, that should say 64. Let me slide it a little bit. 41 plus 70 makes 111. We can move this down. 73 plus 38 makes 111. 73 plus 30 makes 103. Okay? Pretty simple. Add up two angles. That's the angle addition postulate. We're going to skip by this one. I don't like that question. Okay, but this question's better. SPR is 60. SPQ, this whole thing, is 120. What's this one over here? Maddie? 60. Because 60 and 60 make 120. All right. Knowing symbols. Okay? These are called tick marks. If you have tick marks between two line segments, that means they're equal in length or they are congruent to each other. The congruent symbol is this symbol in between. An equal sign with a little whooshy over it, okay? That is the congruent symbol, which means they are the same length, the same size, the same whatever, okay? So the one tick mark is congruent to the one tick mark. The two tick marks are congruent to the two tick marks. But PQ is not congruent to AB because this has one tick mark and this has two tick marks. So they're not congruent. So you have to use the same number of tick marks to say things are congruent. Same with arc marks. Arc marks allow us to say that angles are congruent. So these two angles are congruent and these two angles are congruent. All right. Properties, and I'm not going to worry about these properties too much until we get into proofs a little later, but these are properties that you'll need to know. The reflexive property, AB equals AB or angle A equals angle A. It's like you put a mirror right on the congruent symbol. Each side is the exact same thing. They're reflexive. They're the reflection of each other. The symmetric property is when you flip things on each side of the the congruent symbol. So if AB equals CD, that means CD equals AB. So if 1 equals x plus 5, then x plus 5 must equal 1. Okay, that's the symmetric property. And the transitive property says if the first is equal to the second and the second is equal to the third, then the first is equal to the third. So if 1 is equal to 2 and 2 is equal to 3, then 1 and 3 must be equal. Okay, so those are 3 properties. Not huge today on what you need to know, but you will need to know them later. Okay, but they stick them in now in the first section. Okay, XWZ, this whole thing here is 127. I know this is 32. Because of this tick mark here, and this tick mark here, how big is this one right here? 32. So if this is 32, this is 32, and this whole thing is 127, what's the missing part in the middle? How do I find the missing part in the middle, Jillian? Exactly. Add 32 and 32, so make 64. Subtract that from 127, and I get 63. So the missing angle is 63. And I think that's it. That is it. Okay. So there's a lot of stuff that we just went through. But the good thing is we only have one assignment for today, and we get out at 11:19. What does that mean? That you have close to an hour to do 22 problems, and you think, oh, that'll be easy. Well, only about one person got done last period, okay? They take a while. There's a lot of thought that goes into some of these. So, log into savasrealize.com, and let's start working on the problems. Now, let me go to Savas Realize. Boom. And I think it's there. Savas Realize. I got to go to your class. Geometry number 2. The beginning of the year assessment, I'm going to hide because you don't need to do that because we did the Smarter Balanced. And those of you who didn't do the Smarter Balanced yet, or not Smarter Balanced, NWEA, we'll get you caught up with these next study halls. Okay? But you want to go and find the Math Excel for School Practice and Problem Solving Copy 1. Is that out there for you? Okay, go find that and get started on that. If you get a problem wrong, do similar exercise until you get it right. Keep working. Keep working and keep working. Don't just settle for having wrong answers and it's wrong, it's fine. That's not good enough. I want you to get the right answer. So work until you get the right answer. Okay? So I'm here for any questions. Miss Frank will stay in here for any questions as well. Some days she'll go out, but she'll be